Only the names have been changed. The story you are about to hear is true. Only the names have been changed.
August 2025. While most of us were going about our daily lives, astronomers made a discovery that would redefine our understanding of the cosmos. They found something lurking in the depths of space, something so massive, so incomprehensibly large that it challenges everything we thought we knew about the universe. A black hole. But not just any black hole. This cosmic monster contains the mass of 36 billion suns compressed into a single point in space. To put that in perspective, if our sun were the size of a marble, this black hole would be larger than Mount Everest. And here's where it gets even stranger. It's shaped like a horseshoe, a cosmic horseshoe that might just hold the key to understanding the universe's greatest mysteries. The story of the Cosmic Horseshoe begins with a technique that sounds like science fiction, but is very much science fact: gravitational lensing. When light from a distant galaxy travels through space and passes near a massive object, like a black hole, that object's gravity is so intense, it literally bends the light around it, like a lens. This creates distortions, arcs, and sometimes horseshoe shapes. In August 2025, astronomers analyzing data from multiple telescopes noticed something extraordinary: a perfect horseshoe of light, wrapped around a point of absolute darkness. When they ran the calculations, the numbers were staggering. This wasn't just another supermassive black hole. This was a titan among titans, 36 billion solar masses. To understand how absurd this number is, let's compare it to what we already knew. Sagittarius A star, the supermassive black hole at the center of our own Milky Way galaxy, contains about 4 million solar masses. This discovery, it's 9,000 times more massive than that. The black hole known as TON 618, previously one of the largest ever discovered, weighs in at about 66 billion solar masses. The Cosmic Horseshoe, at 36 billion, puts it potentially in the top 10 most massive black holes ever found. But here's what made scientists stop in their tracks. According to our current understanding of physics, this black hole shouldn't exist. So what exactly are we looking at when we see the Cosmic Horseshoe? Behind this supermassive black hole, there's a distant galaxy, billions of light years away, emitting light. As that light travels toward us, it encounters the black hole's immense gravitational field. The gravity is so powerful that it warps the fabric of space-time itself. The light doesn't travel in a straight line anymore. It bends, curves, and splits around the black hole. From our perspective on Earth, we see multiple distorted images of that background galaxy stretched and magnified into the shape of a horseshoe. The center of the horseshoe, that's where the black hole sits, invisible, but its presence undeniable. Now let's talk about scale, because this is where things get truly mind-bending. Our sun has a mass of about 2 times 10 to the 30th kilograms. It's 109 times wider than Earth. The Cosmic Horseshoe contains 36 billion of these suns, all compressed into a region of space defined by its event horizon, the point of no return. If this black hole replaced Sagittarius A star at the center of our Milky Way, its event horizon The boundary beyond which nothing can escape would extend far beyond the orbit of Neptune. Our entire solar system could fit inside its gravitational death grip multiple times over. Near this monster, space-time is bent so severely that light itself struggles to escape. Orbiting just outside the event horizon, photons of light would circle the black hole, trapped in what scientists call a photon sphere. And time near the Cosmic Horseshoe would slow to a crawl compared to the rest of the universe. What feels like minutes to someone near this black hole could be years, decades, or even centuries elsewhere in the cosmos. Here's the problem that's keeping astrophysicists up at night. The universe is approximately 13.8 billion years old. That sounds like a long time, and it is. But when it comes to growing a black hole to 36 billion solar masses, it might not be long enough. We know how black holes form. When a massive star, say 20 to 30 times the mass of our Sun, runs out of fuel, it collapses in on itself in a catastrophic supernova explosion. What's left behind is a stellar black hole, typically just a few dozen solar masses. These black holes can grow by consuming nearby matter, gas, dust, even entire stars. But this process has limits. There's something called the Eddington limit. As a black hole feeds, the matter spiraling into it heats up and emits intense radiation. This radiation pushes outward, counteracting gravity and limiting how fast the black hole can grow. It's like trying to eat while someone's pushing food away from your mouth. Even feeding at maximum efficiency, non-stop, for the entire 13.8 billion year history of the universe, growing from a stellar black hole to 36 billion solar masses, is problematic. So how did the Cosmic Horseshoe get so big? Theory 1. Primordial black holes. Some scientists propose that this black hole didn't form from a star at all. Instead, it could be a primordial black hole, formed in the first moments after the Big Bang, when the universe was so dense and hot that fluctuations in matter could collapse directly into black holes. Theory 2. Direct collapse. In the early universe, gigantic clouds of primordial gas, hundreds of thousands of times the mass of the Sun, could have collapsed directly into black holes without ever forming stars first. This would give them a massive head start. Theory 3. Cosmic cannibalism. Perhaps the Cosmic Horseshoe is the product of countless mergers. Over billions of years, smaller supermassive black holes at the centers of galaxies collided and combined during galactic mergers, each collision adding to the mass until this. We know black holes merge. We've detected the gravitational waves they produce, but mergers on this scale, we're only beginning to understand them. The truth is, we don't know for certain, and that's what makes the Cosmic Horseshoe so important. It's not just a discovery, it's a challenge, a cosmic puzzle piece that doesn't quite fit the picture we've built of the universe. So, what would it be like to encounter a black hole of this magnitude? Imagine a spacecraft approaching the Cosmic Horseshoe. Long before you reach the event horizon, you'd notice something strange. Your clocks would start running slower compared to the rest of the universe, not because they're broken, but because time itself is slowing down. And then there's spaghettification, the process where tidal forces stretch objects into long, thin shapes like noodles. But here's something counterintuitive. Because the Cosmic Horseshoe is so massive, its event horizon is enormous. The tidal forces at the event horizon would actually be weaker than those of a smaller black hole. You could theoretically cross the event horizon of the Cosmic Horseshoe and not even realize it until it was too late to turn back. But should we be worried? Could the Cosmic Horseshoe threaten Earth? Not anytime soon. This black hole is billions of light years away from us. Light from its vicinity, traveling at 300,000 kilometers per second, has been traveling for billions of years to reach our telescopes. Still, it's actively feeding. As we speak, the Cosmic Horseshoe is consuming gas, dust, and possibly entire stars from its surroundings, growing larger with each passing moment. But the mysteries don't end there. How many more black holes like this are lurking in the universe, hidden from our view? Most galaxies have supermassive black holes at their centers. If some can reach 36 billion solar masses, what's the upper limit? Could there be black holes of 100 billion solar masses? A trillion? And the question that haunts every physicist: what's actually inside a black hole? At the center lies the singularity, a point where our mathematics breaks down, where density becomes infinite, and the laws of physics as we know them cease to function. Or do they? Some theories suggest quantum mechanics might prevent true singularities, creating something else entirely. There's also the tantalizing possibility that supermassive black holes, like the Cosmic Horseshoe, are connected to dark matter and dark energy, the mysterious substances that make up 95% of the universe but remain invisible to us. The discovery of the Cosmic Horseshoe marks the beginning, not the end, of our journey to understand these cosmic giants. The James Webb Space Telescope, humanity's most powerful eye on the cosmos, is now turning its attention to objects like this. With its infrared vision, it can peer through cosmic dust and see things no telescope before could observe. And even more powerful instruments are coming. The extremely large telescope in Chile, with a mirror 39 meters across, space-based gravitational wave detectors that could observe black hole mergers from across the universe. Teams of researchers around the world are now racing to answer fundamental questions. How do supermassive black holes influence galaxy formation and evolution? We know there's a relationship. Nearly every large galaxy has a supermassive black hole at its center, and the mass of that black hole correlates with properties of the galaxy itself. But which came first? Does the black hole shape the galaxy, or does the galaxy create the black hole? The Cosmic Horseshoe might help us answer these questions. By studying its effects on surrounding space, its rate of growth, and its interaction with nearby galaxies, we can piece together the story of how the largest structures in the universe came to be. These black holes might also tell us about the future of the cosmos itself. In the unimaginably distant future, we're talking 10 to the 100th years from now, even black holes will evaporate through a process called Hawking radiation. The Cosmic Horseshoe, with its tremendous mass, will be among the last objects to fade away, the final embers of our universe before eternal darkness. 36 billion times the mass of our Sun. A gravitational monster so powerful it bends light itself into a horseshoe. A cosmic enigma that challenges our understanding of how the universe works, and we only just found it. It makes you wonder, what else is out there, waiting to be discovered? What other cosmic giants lurk in the darkness between galaxies, invisible to us for now, but slowly revealing themselves as our technology improves? The Cosmic Horseshoe reminds us that we live in a universe far stranger, far more magnificent, and far more mysterious than we ever imagined. And somewhere, billions of light years away, it continues to grow, consuming, warping, waiting. What do you think is inside a black hole? Let us know in the comments below. And if you want to explore more cosmic mysteries, hit that subscribe button because the universe has so many more secrets to reveal.